Okay, good afternoon, everyone. Thank you so much for coming in today and attending this seminar. So today we have with us Mr. Barrie Kirk. So Barrie is a well-known keynote speaker, broadcaster, and a consultant. He's an expert in the subject of connected and automated vehicles, and today we have got a seminar on CAVs. Barrie is an executive director of CAVCOE, and he has worked across 3 different countries. He has worked in US, UK, and Canada. And he brings in vast experience across different domains of transportation engineering. Barrie has in the past spoken regularly at different public and private conferences, and includes topics such as smart cities, transportation, insurance, Internet of Things, and it's a vast list. On top of that, some of the work that Barrie has done has been presented in the Globe, Mail, as well as Ottawa Citizen. Barrie has done his electrical engineering from Coventry University in the United Kingdom, and he's a professional engineer. We thank Barrie to take his precious time and coming in here for the seminar. He has previously also given a seminar for York students, and everyone really appreciated that. We thank you again, Barrie, for taking your time and helping the students gain from your vast experience. So, Barrie, the stage is yours. Yeah, feel free to share your screen.
Okay, indeed. Thank you, Pratik, for the introduction and also for the invitation to be here. I really enjoy these. So, and let me put my slides up. Can you see the title slide? Pratik,
yes, we can.
Okay, good. Okay.
Perfect.
Good. Perfect. So, thank you, Dane. So the title today, as you can see, is Deployment and Impact of Connected and Automated Vehicles. I plan to talk for about 30 minutes, maybe a little bit longer, and then we'll have a Q&A session, and which I always enjoy. So, now, my slides, there we go. Just a few words about CAVCOE itself. We are a consulting company, and we provide information, education, advice to corporations and governments on how to prepare for the era of CAVs. I'll say CAVs a lot, connected and automated vehicles. We ourselves do not develop hardware or software. We are consultants on the deployment side. So we've got no vested interest here. I won't go through those client lists, but we also, as you see at the bottom, have a speakers bureau. I'm often asked how I got to where I am today, and I've spent my entire life on the leading edge of technology. I've really enjoyed it, and I'm still there, involved in some innovative telephone design, data networking, satellites, cell phones as traffic probes, and connected vehicles. And from there, it was a fairly short hop and a jump into automated vehicles. It's fun and it's wonderful. I like to brand myself as a futurist with a passion for history. I believe that the best way to understand the future is to have a focus on the history as well. And I won't go through all of this, but it's interesting that it was in 1885 that there was the first car that was widely regarded as practical. But it was another 23 years beyond that before the first mass-produced car, the Model T. And it shows the elapsed time to reach mass production. It's also interesting to me that it was 125 years ago that Nikola Tesla, that great inventor, proposed an automated car which, quote, left to itself, could perform a great variety of operations involving something akin to judgment. So Nikola had this vision for a self-driving car, even though it was another 10 years before the Model T came out and 83 years before IBM launched the first personal computer. So he was really way ahead of his time, had a marvelous vision. My messaging today is that for CAVs, the ecosystem has already started, but gradually. There's a broad range of use cases, not just passenger cars, and I'll come to that, but the deployment of CAVs will not be a light switch moment. If you look back at the 100+ years since the Model T, cars have continued to develop year after year. It'll be the same thing with CAVs. What we see today are the early prototypes, but we will see ongoing development right through the rest of this century, long, long time. This is my agenda. I want to describe the various use cases for CAVs, then deployment, then the impact on virtually everything, and some career opportunities. And there are really three different kinds of CAVs I want to focus on. There's passenger CAVs. Everybody talks about cars, self-driving cars. But as I'll show you, freight CAVs and service vehicles that do work and carry neither passengers nor freight. Freight and service vehicles will be dominant in this decade. Passenger CAVs will see an early start, but the real deployment will be in the 2030s. And here are some ideas about what the passenger CAVs will look like. One on the left is a GM Cruise. You can see on the bottom left, Ford, Waymo, and on the bottom right, a small 4-seater pod made by a company in the UK. And virtually every major car manufacturer is working on CAVs of one sort or another. This is a couple of concepts, the one on the left by GM, no steering wheel, no pedals. And interestingly, GM has to, or in fact has filed with the US government for some changes to the safety regulations. Now, CAVs will be safer than human-driven vehicles, but you still need changes. In the US and Canada, there's a requirement that cars have a airbag built into the steering wheel. If there's no airbag, then that regulation makes no sense and cannot be met. So what GM has proposed is that there are airbags left and right, just this, which are really a mirror image what you have today on the passenger side. Mercedes-Benz have a concept, you can see there, and the front seats swivel, and you can see in the far right-hand side, there's a steering wheel, so the person on the right can either put the car into autonomous mode or swivel around and drive it the old-fashioned way. What is less well known is there's a lot of work on freight CAVs, and you can see the four different categories: long haul, middle mile, last mile, and some special applications. Sometimes I'm asked, well, surely when 18-wheelers start being autonomous, we'll still need truck drivers. And this Volvo prototype, this is a working prototype, shows you don't. There's no cab, and it's designed to be completely autonomous. In Toronto at the moment, there's a commercial service. The customer is Loblaw. The company providing the vehicle is Datic, and that's delivering goods from a Loblaw warehouse to a customer fulfillment center. And what's interesting is after a couple of years of a pilot project, Datic and Loblaw are operating this vehicle with nobody in the driver's seat, fully driverless. At the moment, there is a human in the passenger side with a safety button, but the standby driver is not in the driver's seat. That's a service, not a pilot. You've got underground and delivery vehicles that are autonomous. And there's some special cases. This is an autonomous carrier for air cargo, suitcases and so on. This was developed by a company in Coventry, Origo, and they have some people working here in Ottawa. And this is a pilot project with British Airways at Heathrow. There's an increased number of sidewalk-friendly robots for delivery of groceries and pizza. This is a dispatch one, and you also have Tiny Mile. Now, at the moment in Toronto, these sidewalk robots are banned until there's a method in place to manage them. They're concerned about these robots causing harm to people, especially people who have disabilities, people in wheelchairs, people who are blind and can't see them. So the City of Toronto Council has pushed the pause button on that. And a bit more futuristic, UPS a while back did a pilot project, and you can see above the van a drone. And when the UPS van arrived at a delivery point, the roof would slide open, the drone would lift out with a parcel, deliver it to the home, and then return. And even if the UPS van moved down the road, the drone could in fact follow the mothership and then land. Again, that's just a concept, but it did work. Ford has a different kind of delivery robot, one with legs. And we have this ongoing conversation as to whether legs or wheels are better for small robots. And that's, we don't know at the moment. There's also service applications. And I'll give you a few examples from that list. One is mining. Volvo has launched a whole series of mid-size mine ore carriers at mine sites, and you can see 4 of those working there. Komatsu, the Japanese company, has a wonderful strategy to have a mine working on artificial intelligence, and at the start of the day, the plans for the day are loaded onto the equipment and the mobile equipment, the fixed equipment, and everything will happen autonomously. And Komatsu has said it's fully committed to this. They're not there yet, but they're moving towards that. Farming, you can see one on the left there, company that used to be called DOT, based just outside Regina. It was then taken over by a US company called Raven, fully automated farm equipment. And on the right, John Deere has a different model, but same sort of idea, fully automated farm equipment. And let's be honest, this is the sort of thing that will deploy far more quickly in this decade, because you don't have the same safety issues on a farm that you do in downtown Toronto or wherever. Yeah, you still don't want to hurt people, but it's easier to solve safety issues on a farm. In Kitchener, there's a company called Swap Robotics that has developed and is now marketing fully automated snow plowing equipment, especially for sidewalks. I've seen this operate, and it's wonderful. The same company also does sidewalk inspections, and that is in fact a monitoring system and looks for cracks and unevenness in sidewalks. And a number of different municipalities around Ontario have run pilot projects with that. And also, there's a pilot project in the Netherlands for garbage collection. In many places, you have a 2-person crew, one person driving the garbage truck, and another person picking up the garbage bins and putting the garbage into the truck. This one, you have one person going down the sidewalk, and the truck is autonomous and simply follows the human being. For some reason, which I don't quite understand, this current design, the truck goes backwards, but I understand that'll change in the future. In terms of deployment, there's a whole bunch of things we can talk about. Timing. This decade, despite all of the publicity about passenger cars, the real action this decade will be on freight cabs and service vehicles. They are going to be deployed in volume, mainly because you've got very solid business cases. You can save having drivers more efficient, and the safety issues are easier to solve. For the passenger vehicles, the car manufacturers are, first of all, very focused on electric vehicles. They are very focused on advanced driver assistance systems. We call them ADAS. These, in fact, do things like automatic emergency braking, lane assist, parking assistance, intelligent cruise control, and so on. These are not full CAV capable, but they are stepping stones to that. This decade, we will see some limited deployment of fully automated passenger vehicles, but that will be in controlled environments, limited capability. But when we get into the 2030s, we're going to see fully automated passenger vehicles that can go anytime, in almost any weather, rather like that GM concept with no steering wheels and no pedals. From a technical point of view, there's a lot of technical challenges, deployment challenges that are known, they're being worked on. And one of them is not really technical, it's public acceptance. A US study shows that the public is still very cautious about being in a self-driving car, and they also realize they don't really know enough. And the study has shown that the more people know about self-driving cars, the more willing they are to accept them. Cybersecurity, I'll come back to, all sorts of things, pedestrian prediction. For example, I live in a suburban area of Ottawa. If I'm driving home and there's 2 or 3 kids playing soccer and the ball rolls out into the middle of the street, then I can, in fact, slow down in case one of the kids, without thinking, chases after the ball. Robo-taxis are coming, and they, in fact, have started. There's multiple names for this. The most common one is robo-taxis, but mobility as a service, personalized mass transit, and so on. And there will be, over the next 20 years, increasing use of fully automated taxis. There will be reduced personal car ownership. Personal car ownership will not go away, but I can see, for example, around where I live, if you've got a typical 2-car suburban family, they might sell 1 car and use fully automated taxis for the rest of their transportation needs. It'll change a lot of business models, and it'll work rather like Uber. And in fact, over 2 years ago, 2.5 years ago, Waymo started its first fully driverless robo-taxi service in Phoenix. Since then, there have been a bunch of other ones in China and in the US. So they're coming, but these tend to operate in a geographically limited area, and some of them only really work at night when the traffic is lighter, just to minimize the risk. Tesla has said they'll get into this business, and Elon Musk says theirs will be a combination of Uber and Airbnb. The impact of self-driving cars will be huge. I mentioned earlier 1908 when the first Model Ts came out. Even though Henry Ford was a wonderful innovator, even he, I don't think, could have foreseen the way the first cars changed everything in the 20th century. Changed employment, corporations, business plans, government, and changed society as a whole. And now, over the next 10, 20 years, self-driving vehicles will change everything all over again. The biggest benefit is fewer collisions. CAVs have the potential to be a lot safer. Studies show that 93% of collisions involve human error. Now, this study is frequently misquoted. People say over 90% of collisions are caused by drivers. It's not that simple. The study says that a lot of collisions have multiple causes, and humans are a factor in 93%. My hope, my prayer is that we can, with full deployment in the distant future, we can reduce collisions to 20% of where they are now. This is a screenshot from a presentation given by Mary Barrie she's the CEO of GM. And what I disagree with is they talk about zero crashes. Volvo has spoken about a crash-proof car. Vision Zero is a wonderful initiative, but again, I've called them out in public because they and everybody else are really misleading the public to talk about a utopian future with zero crashes and zero fatalities. All of those people I've mentioned did it wrong. They're the great goals, they mean well, but it's unachievable. I'm an engineer. I know that all hardware, all software fails occasionally. I also know that 7% of collisions have nothing to do with the driver, and they will happen whether a human or computers doing the driving. Bottom line, there will be collisions, fatalities, and injuries, but far fewer than we have now. This is the most argumentative slide I put up. If the data shows eventually that computers really are safer drivers than humans, should we, at some point in the future, ban human drivers? I predict that once we get, say, 10 years into the future, we need to have that conversation. Is it ethical to allow humans to go out and cause all those deaths and injuries when there is a safer technology alternative? There's also a social aspect. I was on a radio show a while back with CBC, and the issue was whether Suncor's use of driverless trucks in the oil sands put truck drivers out of work. And because the unions hate the idea, and there will be pushback. There's a bunch of enabling technologies. I won't go through all of these, but they are key, and they are all linked to helping CAVs do what we expect they will do. One at the bottom, blockchain, it's a maybe. It's got potential, but there's some big issues there, and so it's important to mention it, but with the qualifier that it's maybe. Cybersecurity is a huge issue. People are concerned about it. The bottom line is the bad guys have a lot of money. They can hire clever people to try and defeat cybersecurity issues. There's a lot of money being spent to make hardware, software safer and more secure. Bottom line, this is an arms race that neither side will win outright. And it's unfortunate but that's the reality. It's going to, the issue will be with us for the foreseeable future, and it will cause issues. We in Canada have a bunch of different CAV test sites across the country, and I won't go through all of these, but they are very active in these spaces, and I've been to a bunch of these, so it's wonderful, and it shows the kind of ecosystem we have. And career opportunities, your students, including graduate students. And I want to give you a look ahead at what's possible. On the one hand, there's a huge number of jobs in the CAV industry. But I was talking a while back to a major engineering company in Canada. And even though they're in the technology industry, only 20% of their employees are actually doing STEM type work. The other 80% are in the ecosystem and doing those things I mentioned: marketing, sales, advertising, and so on. And my message is that the CAV industry and in general, the technology industry is a wonderful place to base your career. But to be realistic, not everybody has the DNA to be a software coder. And so there's many other things that people can do in this area, and have a lot of fun, make money, and have a lifetime career. This is a busy slide. This is an infographic of the ecosystem, CAV ecosystem here in Ottawa. And what I like about it is the fact that it's segmented into different categories. You've got solutions, connectivity, safety and security, software and data, sensors, manufacturing, engineering, and design. And there's a really strong ecosystem here. That's wonderful. And this is a similar chart infographic for the Waterloo area. A lot of different companies there. There's a very strong CAV ecosystem there as well. But the flip side is that there will be disruption. A lot of different industries will change as CAVs are deployed, and basically any job that involves cars, involves driving, could be disrupted. And I won't go through all of these, but obviously bus drivers, courier drivers, auto body repair, lawyers, traffic police, they will all change. The jobs will change. Some of the jobs will disappear. And my hope is that governments will step up and provide safety nets. But there will be a human cost. And my forecast is that this will lead to social unrest and union pushback. And my example is a few years ago when Uber drivers first started working, there were tensions and clashes between traditional taxi drivers and Uber drivers, and we can see the same thing happening again. And also an impact on governments. I chaired a workshop a while back, and a mid-level manager from the provincial government said at the end, she realized for the first time that virtually all departments in all levels of governments will be impacted by CAVs. And again, I won't go through all of these. I want to just pick on one, which is police. And impact on police includes there will be, with full, well, as deployment increases, there will be fewer collisions, less drunk driving, and computers will be less likely to run red lights and run stop signs and so on. And all of that is good. It means less workload for the police. But when I talk to police officers, which I have, they tell me that traffic stops have two purposes. One is to find out if the driver's been drinking, but you can also catch a lot of people who have perhaps been banned from driving, shouldn't be driving, are wanted for one reason or another. And, they tell me it's interesting, if you've got a ride traffic check before Christmas and a car comes up and then does a quick U-turn and speeds away, then that's a red flag and they go and chase after that driver. If there's less illegal driving, less speeding, less red lights being jumped, it means less fine revenue. There's also an issue for the police. If in the future you've got AVs that have only kids inside, or perhaps nobody at all, if the police have to stop that, how do they do that? The issue is there, and that's a work in progress. The bottom line is, even though it's 2023, it seems to me it's just like 1908 all over again. We're at the birth of a new car era. In this case, it's because the CAV era has started. As I said at the start, the big movers this decade will be freight and service vehicles. They'll be deployed in volume. And by the way, rhetorical question, guess who operates more freight CAVs than anybody else in the world? And the answer is Amazon. They use robots to move cargo around their mammoth warehouses all over the world. They've even bought their own robot company, and robots are a form of CAV. But again, as I said before, it's a lot easier inside an Amazon warehouse because you've got very tight rules. You don't have kids and dogs, and that's why they've got so many robots. This decade, there will be limited deployment of passenger CAVs. That will change in the 2030s when we get large-scale deployment. From my perspective, and hopefully from yours, the CAV system is exciting, it's growing. There's a wide range of technologies and use cases, and for you, business opportunities, many jobs and career opportunities. And I look forward to seeing you in the CAV ecosystem in the years ahead. And finally, this is my name and email address. We publish a free monthly newsletter called CAV Update, and we strive to have roughly a 50-50 balance between Canadian CAV news and international CAV news. And we'll be publishing the January version tomorrow, actually. So if you're interested, as I say, it is free. So just write to me or to write to that address shown there, cavupdate.subscribe@cavco.com, and we'll put you on the mailing list, and it'll help you to keep up to date with all the things that are happening in this ecosystem. So that's the end of the prepared presentation.